this?
I felt like this was a little bit easier just because it was kind of just played on Monday's homework.
Yeah. Can I on part one, number three? How do you figure out the 40th percentile thing? The B. What is the 40th percentile for this population?
Hold on just one
For
second.
that one, I saw that somewhere. I think I just put point 0.4 in the area part, the top thing. And maybe, hold
I'm
on.
pretty sure what I did, it was like the mean minus the standard deviation times, what was it? It was times something.
Yeah, I didn't understand where the 0.25 whatever came from.
If you put point 0.4 into the area, the top thing in the applet,
Yep.
then it gives you 0.253.
Yeah.
Uh, okay. Got you. Thank you. Did you guys finish part two?
I still have 2 left. I was just doing it, and it took me forever to figure out how to do it, like when it was saying if it's greater than 36 or whatever. But I just figured that out, and so now I've been doing them. Yeah, I'm
That's
good to go on with whatever.
I'm only on number 6.
Okay.
Okay. Sounds good.
Yeah, I didn't do 7 or 8.
Okay.
So I'll do those right now.
So on number 6, you're using the applet, right?
Yeah.
So for greater than 40 in the area part, you put 0.40
No.
and then no?
What I did. No. I had to use the formula, and I got the z-score of -1, and then I plugged that in, and that's what gave me the probability.
Yeah. That's what you're supposed to do.
So my formula, I don't know what like the actual thing is, but I did 40 minus 45 divided by 10 over square root of 4.
All right, and that's to get the z-score.
That's to get the z-score, and then you plug in the z-score, -1, and you want less than 40, so I think it's just the left one.
Yeah, it is. You just shade in everything on the left side.
Yeah.
So for number 7, I'm sorry, you guys, you have to figure out 2 z-scores, right?
Yeah, except for they're the same exact thing. One is positive and one is negative. So, I mean, you can just figure out one, plug it in, and it does the positive and negative, and you just want the middle section. Did you get that one, Renee?
Almost. I'm just going to the applet. So it's -2 and +2.
Yeah.
Yeah. Oh, sorry.
Bless you.
And then you just want the area of the middle. Because that's between the
Because
two
it's
numbers.
between them, right? It was 0.9545.
Yeah.
0.9545.
Did you eat that chicken too?
Mhm.
Did you eat that chicken too? Which one are you on right now, Renee?
8.
Okay. Yeah, pretty much like now until the end. I guess there's a couple that are different. But all the ones that you have to calculate, it's that same formula that you use.
I'm messing up the z-score though somehow.
On number 8.
Yeah, so the first one is 41 minus 45. Oh, which, never mind, I just figured it out. It's not 10. All right, I don't understand that one. So if your z-score is -2 and +2,
Mm-hmm.
and you're looking for the probability that it's greater than and less than, oh, I see, because those are the standard deviations, right?
Yeah, it's the same exact thing as number 7. So if it's -2, then you're just looking for the area between the two.
Oh, yeah. I got you. I was looking at less than 41 and greater than 49. Wrong way.
Yeah, so you should get the same answer as number 7.
Yep. Are you guys both just waiting for me?
Yeah, it's fine though.
Yeah. It's all good.
You don't have that much more, and like 10 through 12 are super easy, and 13. And then all the rest are just
Alright.
the ones you're doing.
Well, I'll skip 9 then, because if that's the same thing.
Yeah, 9 is just like the same thing, except you're not looking for like in between two numbers. You're just
Yep.
doing 100 and 50. So you just find the z-score, and then it's whatever is above that.
All right, so 10, got that. Okay, and then 14 and 15 are just the same thing that we were doing before, right? You're looking,
Yeah,
you're plugging in, you're finding the z-score and plugging in the applet.
yeah, it's the same thing.
Yeah.
Okay, I'm ready.
Okay. Did you guys do number 3 yet?
I just opened the quiz.
No.
Let me go back and reread the question here and make sure I'm plugging in this thing right. Right and to the left.
Did you guys get an answer yet?
I've got one.
What did you get?
I have 0.175.
Okay, that's what I got too.
Yeah, that's what I got.
I don't like this class, especially at 10 o'clock at night.
Oh yeah. Gosh, that's terrible.
Is this one using the same formula?
What?
Is number 4 using that same formula we just did a million times?
Yeah, I'm pretty sure.
So we're finding the z-score of the 177.6, right?
Yeah.
Yeah.
That's what I just. Did you guys get an answer yet?
Almost. Give me one more second.
So I got an answer, but I'm not sure what things have to be blue.
All right, I have one that
What's your z-score?
1.068,
Oh,
negative 1.068.
Sam, what's yours?
One more second, sorry. I did it on Excel, so I'm plugging all the numbers in. Mine's off. I got negative 2.6. Hold on, just one second.
Did yours not match either of those, Kelsey?
No, I got negative 1.92.
All right, so how did you want to walk through how we got it? You do 177.6 take away 185 divided by 26.7 divided by the square root of 48.
Yeah.
Does that match anything?
Wait, what was your answer that you got?
Negative 1.068.
I did the same thing, but I didn't get that answer. I'm gonna do it again.
Oh, wait a second. My answer's changing.
Wait, they don't give us the standard deviation, do they? Oh wait, never mind, just kidding.
Oh, nope, you're right. Negative 1.920.
Yeah, that's what I got.
All right, so then if we go to the...
So isn't everything to the right of negative 1.920? Or what is it?
I think it's to the left.
Well, the note, though, as extreme or more extreme means we're not only interested in values that are lower than, but also values that are as far away from the mean as ours in the positive direction.
So the left and the right and not the middle?
Or is it everything in between?
Find the value of the Reynolds sum will have a weight that is as extreme or more extreme, either above or below the mean. So I think it's left and right.
That's what I'm thinking too.
Which is 0.0549.
But you have to round it to 0.055.
0.055. Oy.
I think 5 is the first one. Oh wait, smaller standard deviation? Never mind, I think it's the second one.
Oops.
Because the means would be closer together than just like the random things all spread out. Right?
Standard deviation of 9.
Randomly drawn from a population.
Because the means would bring everything closer, but if you just did like the 9 observations, there's going to be some way over here, some way over here, and the standard deviation is going to be bigger.
Well, in the notes where it was talking about the distribution of the sample means when the parent population is not normally distributed, it said if the standard deviation of the population is whatever, then the standard deviation of the distribution of sample means, which is the middle one, is that divided by the square root of the population. So that's going to give you the smaller number because you're dividing that original mean by the square root of the number.
So it is the second one?
That's how I read it, but
I think it's the second one too. That's the only one.
Yeah.
I'm open to arguments.
No. Hold on.
I was under the impression that this class was going to be in English. And decreases as the sample size.
I don't really know for number 6.
Which?
It's one of the last two. I just have to figure out which one. Is it? As the spread decreases. Isn't that central limit theorem? Because the spread is talking about the shape of your sample, right? So if it's way spread out, but
This is the spread of the decreases. Does that change anything?
well, in central limit theorem, as the sample size increases, the means becomes then approximately normal, or the law of large numbers is as the sample size increases, the mean draws closer to the population mean. So that, I don't,
Those don't really.
the central limit theorem is the one that's talking about the shape of the, what are we talking about? So that, and the spread is talking about, no.
But didn't you say that the central limit theorem, like, as the sample size increases, it becomes normal?
Yes.
Yeah.
But why would it not be the first one, the normal distribution, then? Because I feel like that's just getting to the normal distribution.
Implies. That, I could go with that. That makes sense to me.
I don't know.
Something.
The normal distribution one, that one doesn't really change. Because it's saying that the spread as the sample size increases. Maybe it is the central limit theorem.
So as the spread in the sample mean decreases, I don't know. What do you guys think?
I think I might go with the normal distribution. I feel like that makes a little bit more sense in my head, but I don't know.
Yeah, it's either that or central limit theorem. But I don't know. It's just my mind.
Oh man, why can't this just be what's the distribution? Normal. I know that one. What's the z-score? Okay.
Okay, I got 1.045.
Oh, so this one doesn't have the square root because we're just doing the sample, right? Or the parent population. What did you get?
1.045.
Yep, that's what I got.
For number 7?
Yep.
Yeah, okay. That's what I got too.
And then I got 0.148 for number 8.
So that's using the applet, right?
Yeah. And then number 9, I got the same thing as number 6. Because the mean of all those numbers is 160.
Wait, on number 9, you said you got the same answer?
Yeah, well, I just found the mean of those numbers and then used that, and I got the same thing, because the mean is 160.
Right, but this is the random sample, so isn't that the one where we have to do the square root?
Is that 5 then?
Yeah.
Okay.
Oh, okay. So let's see.
I got 2.338.
Yes, that's what I got.
And for number 10, I got 0.009. Oh wait, 4 places. 0.085.
00 what?
0.0085.
I got 0097.
For number 10,
Yep. Did you get 2.338?
yeah, and then you do the right one, don't you?
Yep. So you put in 2.338.
Oh, wait, hold on. Oh, I put 2.388, that's why.
One.
Okay, so 0.0097.
That's what I got.
I got 9.4. Hold on. Let me. Oh, okay. Got it.
Okay, is 11 approximately normal because it's a bigger sample?
Yep. That's what I think.
Yeah.
How do you decide, like, what's a bigger sample and what's a smaller sample?
Right?
I don't understand that because he's only used, like, 4 as a smaller sample and, like, really big numbers. So I don't know where it's off.
I think something either that I read or that I heard in the video, they were saying like over 40 or something.
Oh, okay. I don't understand number 12.
Random sample of 81. Okay, what is the mean of the distribution of the sample means? 81 that could be drawn.
What is the
I don't understand that question.
I don't understand.
Yeah, neither do I.
And the next 4 are all together.
Of course. All right. What is the mean of the distribution of the sample of these? Okay. If the mean of the original population is 81, right, or what's the mean that we're talking about up there?
The mean is 3.5.
Yeah.
Okay, so if the mean for the original population is 3.5, then the mean of the distribution of sample means is also that. So I think it's the same, 3.5. And that was true whether it's a normal or abnormal. Not abnormal, not normal.
So even though it's less skewed, it's still 3.5?
Yep, according to my notes from the...
Is that what it says about standard deviation too?
Standard deviation is also the same. If the standard deviation of the population is whatever, then the standard deviation of the distribution of sample means, oh, no, is that divided by the square root of the number. So the mean is, no, the standard deviation, 0.7
divided by the square root
of 81.
Okay.
Wait, the standard deviation divided by 9?
Yep.
So 0.078?
Yeah. That's what I got.
And we're going to 3 decimal points, so yep, 0.78. Oh, here's the probability one. Less than 3.3.
So is it just 3.3 minus 3.5?
Right, is we have to find the z-score for that, right?
Yeah. So that's negative 0.2. I got 2.57.
Yeah, that's what I got. Negative 2.571.
Negative?
I got negative for some reason.
Oh yeah, I got negative 2. Sorry.
Oh, okay. I was like,
So 0.005. Is that what you guys got?
for what?
Did you guys get 0.005 for number 14?
Yeah.
Okay. And then number 15 is just the opposite of that, so 0.995.
Can we go back to 14 for a minute?
Yeah, that's fine.
14?
So when we're figuring out the z-score for that, we do 3.3 minus 3.5.
Uh-huh.
Negative 0.2. And then you divide that by the standard deviation, right, which is 0.7.
Yeah.
So divided by 0.7 is 2.857, negative 2.857. And then if you plug that into the applet,
Yeah, but
You
you
still
divide
have to do the square root. Yeah.
oh, we have to do the square root of that one because it's a sample,
Yeah.
random sample. All right, divided by the square, well, divided by 9, right?
Yeah.
0.7. So do you get negative 0.857?
No.
Or
Oh, I forgot what I got for the.
For the z-score, I got negative 2.574. But I didn't divide it the way you did it. I did, I separated it like it shows in the equation. And so I did, hold on.
Yeah, I think I did.
0.7 divided by 9. And then I did.
Wait, but it's by the square root of 9, right? Oh, no, 9 is the square root. That's the.
Did it. And that's how I got that answer.
All right, now I get negative 0.257.
Yeah.
But do we want to know?
Negative 2.57.
We want to know if it's less than 3.3, or what's the probability?
You got 2.57?
Negative 2.574.
I got negative 0.257. All right, so 3.5 or 3.3 minus 3.5, that's our negative 0.2.
Yeah.
And then we divide the standard deviation, which is 0.7, by 9, because that's the square root, which is 0.077777.
Yeah.
So now you're dividing 0.2 by 0.7777.
0.0777.
Say that again.
It's 0.0777. We correct 0. When you're dividing it by.
Oh, good. Hey, 2.574. Oh my gosh. But then,
Okay, you got it now.
good grief. So, that's not the answer though, right? We want the area, which is the 0.005.
Yeah.
Is our probability.
Yeah.
We want how many decimals? 0.005.
Yeah, it just has to be 3.
Sorry, guys.
Oh, no, you're fine.
Probability. So greater than, we just take that exact same thing, and instead of shading the left, we shade the middle and the right.
Yeah.
So 0.995.
Mm-hmm.
All right, guys, I submitted it. And what did you guys put for number 6? Because it's not normal distribution if you guys...
I have the central limit theorem, but I haven't submitted it yet.
Okay.
That's what I have too. I'm going to submit mine.
Actually, the law of large numbers, if you guys want it.
It's the law of large numbers?
Yeah.
Well,
Not bad, ladies. Not bad. Painful, but not bad. Wow.
well, I have a ton of homework to do tonight, so
I do too. Thanks, guys. I'll see you on
No
Monday.
problem. I'll see you Monday.
bye.
Bye.